Hey, welcome back to Ye Old Foundry. Okay, now I've gone and showed you the capability of a background or backyard molder slash foundry worker can make things that have been broken that you want to replace. And if you wrap it, give it enough clearance in the mold, your item will be so very close to the original size it just may not matter. Okay, I've already showed you that in the last set. Now, another excellent use of these techniques that I've put out there is for you, if you are a machinist, to be able to make your own raw materials. In that case, what I mean is make your own billets. Okay, if you've got a furnace and you've got molding materials, let's say molding sand like I have, you can take a basic shape. I'll get this, like this PVC pipe. Okay, you get a piece of PVC pipe the size or as close to the size of the billet that you need, and you can use that as a pattern. Of course, how much of this gets poured depends entirely on how much room you have in your crucible. How much material you'll have in your crucible to pour into the mold. You'll have to figure that out yourself. Okay, I probably, let's see, the inside of this, I probably can fill this up maybe halfway, let's say. Okay, I'm going to work under the assumption that I'm making a billet this large. You'll find that is probably an incorrect assumption, but I'm going to work under that assumption. Okay, so you're let's say you're a machinist and you need to make some washers or big pads, something that's going to have to take up a certain amount of room. And you don't want to spend, well, I don't even really know how much it costs to buy a regular billet or buy a chunk of material that would be the size that you need. I'm sure you do. Okay, I've never had to do it, so because I don't have any of the machinery that you guys do, if I'm speaking to a machinist. And so here you've got the capability of pouring molten metal, depending on your situation, how good your furnace is, and so forth. You can pour, I've seen people with the type of furnace I have pour cast iron. Okay, and so if you can pour cast iron, you can pour regular steel. And if you can, I don't know about stainless steel. I'm not absolutely certain about the whether or not the heat is hot enough. You probably melt it, but you might not be able to bring it up to 3,100 degrees. And your furnace lining might not be able to handle that, depending on what you used to make the furnace lining. So anyway, so this is what we're going to do this time. I'm going to show you how to make a billet. Now, this information was covered in the video labeled billets, but this is going to be almost, the billets video might be if you went through college or actually even in a metal shop in high school. The video might be the lab, and that might be the classroom, and this is going to be the lab. Okay, this is where we're actually going to do something. All right. So, but I got something special to show you. In my Navy career, while I knew what this was, I never used that. Okay, a hand rammer, everybody knew how to use it. They knew the technique, ram everything up with a peen, P-E-E-N, end first, and then finish off at the very top with a butt end, B-U-T-T end, of the hand rammer, and that's the way to do it, right? Well, we didn't always Well, actually, we didn't never have this in hand to do those jobs, because in the Navy, if you're given a job, you're expected to not only do the job right, but to try and get it done as quick as possible, because in 5 minutes down the road, you might be given another job. That one has to be done fast, and you can't be in the middle of a job and scrap all that effort to take this one, and get it done really fast, okay? So we had to work with a machine. Now it's a rammer, but it's a pneumatic rammer, okay? I never did look up to see how far back that goes. I would expect that the pneumatic rammers were probably made in the 30s or 40s, 1930s or 40s. Maybe what I'll do is I'll go ahead and try and look that up and see when those were made. But I remember plenty of pictures of where in the 30s and 40s, well, in the 30s, they still had big hand rammers. Things were that tall if you were working on a floor mold. And a floor mold, just in case you don't know, is one that you can't put on the bench. Okay? It's too freaking big. It might be a 24 by 24, 16 by 16, and I'm talking inches now. It might be a 24 inch by a 24 inch, might be a 16 by 16 inch. Or in the big furnaces, it might be 6 foot long and 6 foot wide, internal dimensions, I mean. Okay, so that's a floor mold. It has to be made on the floor. Most of all of our stuff that we made on the ships was bench molds, because the vast majority of them were rammed up in a 12 by 12 flask. Okay, now I'm going to bring out the pneumatic rammer. Now this is the type of pneumatic rammer, a bench rammer, that I was first exposed to when I first came in the Navy, okay? It was less than a decade later that somebody got it, in their head to look up, see if you can buy rammers that are smaller than this, that would make it easier, because this is probably 6 or 7 pounds, and maybe. Anyway, it feels like 6 or 7 pounds. And if you're working with this all day, you're going to be a little bit tired by the end of the day of trying to control this thing. I used to have a good time fooling around with this, because when you put this, it's pressurized now. If you put this under pressure and you're really not doing anything, nobody's nearby, you can pretend that you're one of those sailors in Hollywood trying to shoot down one of those attacking fighter aircraft. And I played around a little bit like it, and this is what it looked like. Okay, had a fun time doing that. But as you see, that's the way these go. These work. Now I'm going to be using this to ram up the pattern here that I just made out of PVC pipe, or cut down to size, made from PVC pipe. Okay, and what we're gonna do, I'm gonna flip you around and show you so I can point everything out easier. Hope you don't get too dizzy doing it. Okay, a little bit better. There. All right. Now basically, it depends on the size of the billet that you were making, but essentially it'll be a 3-part mold. Okay, you have a base. Pardon me. You have a base that makes the very bottommost portion of this. This will be flat. When you pour it, you break it out, and this will be flat. Now it's not entirely necessary, because as you may know, the first thing that a machinist is going to do after he gets this thing chucked up into the after it gets chucked up in the lathe, is that they're going to take this and they're going to clean this off, this end off. So any any amount of pebbliness that the sand gives you, it'll be gone in the first one or two runs, or one or two cuts that the machinist will take. Okay, so you really don't have to make a whole lot of effort to try and make this section as smooth as possible. All right, not going to make a difference in the long run, and it might be just a little bit too much effort to really justify it. Okay, now there's a phrase that I learned in college, and it's escaping me now. Of course, the brain is not all in working on all cylinders, but you can put out just so much effort before it becomes, I mean, the amount of advantage that you get from the effort you put out is well, it runs under the phrase the law of diminishing returns. Okay, you put out a lot of effort to make a nice mold, you're going to have a good casting. You put out even more effort to make things all smooth and all that, you're going to make a nice casting that'll look a little bit prettier. You put out even more effort, but you already made a nice solid casting, and you made a nice smooth casting, and the advantage past that point is really not going to show up that much. The same thing happens when it comes to machinery and machinists. You can spend a great deal of time coming as close as absolutely possible to making the shaft exactly the size the shaft should be, or you can bring it down, make it less than 1/1000th away from the right size, or less than 10,000ths. I mean, it depends on the actual shaft and what machinery it's supposed to be in. You're not going to really have that much advantage if you spend a week on something when you could have done it in a day. Okay, there's always ways of improving your jobs, but is it really going to be worth the time? Especially when you are at a job, the foreman or the supervisor is going to start raising his eyebrow at you if you're still messing around with that same thing that you're supposed to have machined an hour and a half ago. Okay, law of diminishing returns. That's the phrase. So keep in mind that you are going to be making something, and you want to do as good a job as possible, but you don't have to make a life's effort. You don't have to spend the last part of your life making the same thing and making it better and better, because what kind of advantage are you really going to get after all that effort? Okay, so that's that lecture. Okay, now we still, as a molder, we still don't want the molding sand to stick to anything like this molding board. This is going to be fairly thick. I think my last pour kind of charred this up. Anyway, we don't want the sand to stick to this, otherwise you've got to repair it. So get your partine powder, and just give it a light dusting. You just want to have a barrier between the board and the sand. Okay, now you can make it as smooth as possible and put this on there and put a layer of facing sand on there to make it smooth. But as I said, what kind of effort, what kind of real advantage will that be? Okay. Now, the only reason why I'm really just tucking this in is, number one, I am in the habit of it, but number two, I really don't want all this sand to be pushed all over the place by this pneumatic rammer. There's an advantage and a disadvantage of using a pneumatic rammer. Now, the advantage is that everything will get done quite a bit faster, and you'll be able to you'll have a nice solid mold. Okay. The disadvantage is you're going to be pressing the grains of sand together that much more. And if you've been paying attention, those of you who have been watching the videos, you will be diminishing the amount of air passage through the grains of sand. Okay, this will make it even that much more necessary to vent these molds. Okay, now let's get, this hasn't been used probably in 20 years. And it bounced all over the place, but it looks like it should have gotten nice and, yeah, this baby is tight. Okay, there's one thing you won't do is you won't forget to scratch it off, because this for the same reason. And it's even more important now because you really got a lot of compressed sand here, and it's even more discreet from the next layer if you don't. Okay, and by that I mean you'll have a layer, and then you'll have another layer on top of it, and the bottom layer, if it's not thick enough, it'll fall out. Okay, so you gotta get it done, scratch it every time. And this uses air, so my air tank is right over there, and it might come on, so watch your ears. son of a gun, that thing. Anyway, okay. That's solid. That's a lot more solid than I can do with my hand. Makes me very happy that when I made these cheeks, that I used screws instead of nails. Okay, that's vented. Wow, that's nice. Just getting all this junk out of the way. All right. Now I need to try and recover as much of this sand as I possibly can. Well, with this pneumatic rammer being used and everything being compressed even better, I'm not entirely sure I'll have all the sand I need. But I'm relatively sure that I'll have it. But I'm not going to bet my paycheck on it, or my retirement check, for that matter. Okay, let's get this out of the way just long enough to get this sand. Out of the way. Now this is absolutely one of those kind of jobs that if you clean as you go, you save yourself a lot of trouble. Look how much sand is in there. And that's because you've got a lot less control over, you know, the sand flying all over the place when you use a pneumatic rammer. All right. Get a little swig of coffee over here. Now I know I've said it before, but the bad thing about green sand is that you got to kind of work fast. I mean, it's not like you got to work with sodium silicate sand. You know, it's not going to be that fast, but you'll find, depending on what time of the year, also whether it's humid out or where the air is dry out. This is only water and sand and clay in there. Then the water's going to evaporate. Okay, it's not going to evaporate from the inside out. It's going to evaporate from the area that is in contact with the atmosphere inwardly. Okay, so if you've got a lot of hand work to do in here, you're really going to have to hurry up and get that done before everything dries up on you. Now this sand is made with Western bentonite. Western bentonite is known for its dry strength. And so if you get everything done before it dries out, once it dries out, it'll resist any kind of manipulation somebody's accidentally going to have with it. And like somebody walking around or might hit it. Things aren't naturally or automatically going to fall out of place, okay? Like some of the green sand cores that you might be making. If I was a green sand core versus a core, a core and a green sand core does the same thing. It makes a form around which the molten metal will wrap. Okay, and if you make it good enough, it'll conform to every dimension that you wanted it to, and you'll have a indentation or a cavity inside your casting that'll be the shape and size that you needed. Okay, even if you're only making a cover for your what is that, a traveling cover or one? Keith Rucker cast one time. He had, you know, over where on your lathe you've got your tool post and all that on. I guess it's the saddle. Is it the saddle? Don't know. Anyway, where you turn it and the tool goes in and comes out and so forth. Down past where all the wheels are, or handles are, there's the screw, and that wasn't supposed to be out in the open. Okay, you don't really want to have your chips and such getting into that area. So he made a cover for that. Okay, and that was a very easy cover to make. He used a green sand core to make the inside indentation. Okay, the top was flat. Then you had two little walls about, let's say, so tall, and on the inside, and if you didn't have a green sand core in there, you would have a plate of cast aluminum. Okay, it would be flat on top, flat on the bottom. You might as well get yourself a piece of stainless, or rather a piece of sheet metal, and just throw it on the opening right there, and have it like that. But he made a nice cover, and it came out nice. But the indentation on the underside of that was made by a green sand core. If you were to make 1 billion of them, you might be making regular cores, so that you can ram up the pattern, take the pattern out, set the core, put the cope on, and then go pour it. Okay. All right. So this is going to be the very base. This is going to sit like in there. Okay. What I'm going to wind up having, this is kind of easier and kind of harder. Let's unlock it. There's a lot of things that I normally do with a mold that I don't have to do with this one. Okay, I won't have to ram up the drag first, flip it, and then ram up the cope, because basically all you're doing is you're just ramming up a cylinder. Okay, so let's see. I gotta make sure that this baby ain't gonna be too close to anything. All right, hose. Okay, let's give that place. Give that, got plenty of room all the way around. Okay, that's the important part. To have plenty of room. Tell you what, this, I got a stinking suspicion that this rammer just don't want to be used because it keeps coming loose. Right. Okay. And I got crap down there now. Okay. Really don't want to have it start off like that. Okay, now what? I got to make a decision on how the runners, plenty of room for that, okay, plenty of room for that, plenty of room for that, okay. Now, if you saw the one video on billets, was it on billets that I did that? I think so. Anyway, oh, gates, I think I may have covered it in gates. Gates, there's a particular type of in-gate that you use for billets. Now, you're not going to be able to do like in a regular mold and have a pressurized mold, because what you're going to be doing is you're going to be pouring it not just to the first parting line, you're going to be pouring it from the top all the way down to this base here, and that's a long drop. So in this case it's going to be aluminum, so it's not going to be such a bad thing because there's not a lot of dross formed with aluminum. Some, yes, but not a lot. Not like copper based alloys, for instance, you know, brass and bronze. Okay, those guys, you got to do everything you can not to form dross. Anyway, the kind of in-gate that you use on these is called a whirl gate. Now look, we're going to pretend that I'm taking the whole mold and turning it on its side, and we're going to, there's going to be the down sprue hitting the splash basin, hitting the runner, then you're going to have an in-gate, right? Well, you're going to have two of those, two levels. The reason why you have to have two levels, two sets of runners and in-gates, is because you're pouring it a long ways, and if that cools down at all, and it will, because it'll be in contact with this bottom, and it'll be in contact with the sand down at the bottom, that'll start freezing up, okay? If you only have one in-gate, it just might freeze it up before you can pour it all the way. So you need to have, in this case, you'll have a gating system on this parting line and on this parting line, okay? And it's not that hard, okay? It's not that difficult to imagine how to do it. Now, I don't like this thing jumping all over the place like that. So I'm going to try and find myself a couple of either C-clamps or some kind of clamp to keep these together so it doesn't bounce on me like this base did, and make everything all go everywhere, okay? So I'll be right back behind here. Well, I may as well pause you because it might take a minute or two. Okay, as you can see, I got my clamps here. So basically, all we're doing is just gonna fill this thing in, ram it up. Hold on to everything. Don't let things being shifted about. Remember, everything weighs something and therefore has force. You don't want your project to be all knocked askew because you didn't hold on to it. So, now hold on to that. Okay, this thing is working nice. And by the way, this was off of the Yosemite, my last ship. Apparently, when they were when they were getting rid of the Yosemite, they took a lot of the tools and rammers and all kinds of stuff over to the Mayport foundry before it was discontinued and or disestablished, I should say. And the only reason why I know this is from the Yosemite is because somebody had the foresight in the shop to stamp it, yo-yo, on there. Went over to, I just happened to be in the building working on something as an electrician in the what used to be the what they used to call it? SEMA. They used to call it SEMA back in those days. And they said, hey, weren't you a molder? I said, yeah. Is there anything here you want? Said, we got to throw it away if you don't. So and I looked around. They had a full bench of Petrobond sand. Oh God, I wish I could have thought ahead and got the powder that must have been there. Okay, but I wasn't going to haul everything out of there, and I think this was basically the only thing I really saw that I might be able to use. Now I am. Now the thing is, with pneumatic rammers, they are very, very useful. They will ram up things that much harder, and you can't hardly mess up when it comes to you know, making everything conform to the pattern. Okay. So that's all we used. We used pneumatic rammers. There was a time though when the foundry community, you know, screamed and hollered, you know, these things are too heavy. Even the bench rammers are too heavy. You know, they'll be at the bench 8 hours, 12 hours a day with that heavy darn thing in their hands. And so what happened is that the people who make these, whomever they are, I don't know who made this one, made a small one that, well, this one, what is that, maybe 2 foot, 2.5 feet long. The one that we had was maybe that long, about a foot. Okay, used the same amount of air, or the same air, same pressure, and it went really fast. On the bottom, instead of having a flat steel, in this case it's a butt. You see, flat like this, it's the butt end, and not a peen, although I have seen peens on these before. They had on the small ones, and some of the bigger ones later, they had something like this, but on the end of it, it was hard rubber. So you didn't have the real strong piston action hitting maybe your wooden or plastic pattern, which really ticked everybody off. gave me a long enough time for me to remember that I didn't scratch the last layer. Okay. Incidentally, those of you who are using the same formula for sand that I use, I found, I don't know if it's a unique thing for this Western bentonite, but I found that it sure does dry out quickly. So instead of 5% moisture being put in there, this time I tried 6% moisture. We'll see how it goes. Okay. Now in the Navy, on board the ship, our molding area right here, that's where we also stored our sand, because the Petrobond sand, that didn't dry out. Okay, it was a petrochemical setup. That's the only reason why I don't have my sand in here instead of in buckets, because this dries out too darn fast. Alright. Get this out of the way. Very close to the top. Now let's see if we can see what we have over here. Do we have some over here? Oh yeah. Trying to recover as much sand as I possibly can. Got because it's so borderline. I may wind up having to do like Keith Rucker did, at least on one of his molds. Just have it up just so far, and then you have a irregular surface, which is kind of really goes against my grain. Now it came to my, I was thinking about it. So, well, maybe I can just spread this out here, pack it down, and then finish this last little bit with a hand rammer. Problem is, I'm going to be using this pneumatic rammer on the other part here too. So, if I did it, the hand rammer is going to be a relatively soft area of the mold when it comes to this. So if I'm ramming up the top half of this with the pneumatic rammer, it's just going to press that down into this area. We don't want that. Well, my prayers were answered. We had just enough for that bucket to fill in this layer. Okay. Now, what you will have to do is you will have to smooth this parting line out. Okay, now, the reason why we've got to smooth this all out is because we're going to be ramming up. That's nice and hard. Anyway, we're going to be ramming up the next level, and once you take this out, that's going to have to be able to be separate from this. Okay? So, keep things from rising from the pressure. This is nice and tight. Okay. Now, parking, right. Getting drifty in my old age. Just double checking to make sure that the camera hadn't turned off. So far, so good. Now, do I need to worry about that? No, I don't need to worry about that, because these will hold this together and keep it from raising up from my ramming it. Let's put these over here. All right. See if we can use this down in here. Take advantage of every square inch of the sand. Actually, there's a lot more than just a square inch in here. It's a little high up now for you to be able to see, so let's say we raise you up a bit. Now, is that worthwhile? Is that, I'll go down just a smidgen. Maybe that'll help. Be better than the other way, I think. Man, I wish YouTube would let me play my music, but I imagine it's lawfully a little easier on them if they don't have to answer questions about copyright and all that. Spread it all out. I think my little old rammer here is still fighting me, for gosh sakes. I was about to say, I think it's getting used to being used again because it's not fighting as much, but oh, this air hose does not want to stay on. That's absolutely going to be my fault. Okay, scratch it. Scratch this layer. Man, I swear that thing is happening more and more. I mean, it's happening more often than it should be. Okay, now this layer I could do by hand. But I really don't want to. I want to finish the whole thing. Think it's going to be about time to make some more. Anybody recognize that? Double ender, two ends, double ender, spoon, and a leaf, like the leaf off a tree. Mainly made for just finishing out mold cavities. Now once I get this portion done and it's ready to pour, I'm going to try and get the camera above the opening here so that you can see how a whirl gate works. Whirl gate, by the way, for those of you who didn't see that video that I made about gates, because we have a possibility of making dross from the big drop that this is going to have coming down all the way down to the bottom layer first. We need to try and use a trick of physics to almost force the bad stuff that enters this cavity to float to the top and stay floating until this whole thing is done, being poured, that is. Okay? Don't forget you gotta vent. Ooh, that's a lot of, I'm glad I'm venting. That's considerably harder than normal. Now that this is going to be vented, any and all the gases and, you know, vapors can escape the sand easier. There's a certain amount of what's called permeability on any of these sands, okay? It has the capability of naturally allowing gas and vapor to work their way through the sand and get out. Well, the harder you ram it, the smaller the gaps between the sand grains, and well, you might trap some of those vapors and gases into your casting, and then you might just have to do it all over again, depending on how bad the casting defect is. Okay. Let's do this. Let's get this done first, because this is where I'm going to pour it. And I've got to put this sprue in here before we take it apart, at least for this section. And I take away most of the sand, just enough to where this will stay still and form a good pouring basin. Closer. This nice smooth surface here is helping me smooth that out, keeping sand from being gouged out as we're pouring. because you don't pour directly in the middle. Okay, that isn't that big so that you can, you know, prevent stuff from coming on top of here and running, although it does help. This is where you hit. This is where you pour, right on the side. Okay, that way the only real place that you have any drop in a normal mold. Okay, that this is not the same thing. On a normal mold, you don't want it to drop from the edge of the crucible all the way down to the splash basin, if you can ever help it. What you want to do is you want to hit it here so that it runs into there, hits the side of that sprue, and kind of does a miniature zigzag down, and all the time it's filling up this in here, and it's not dropping all the way down and causing a big splash, a lot of turbulence, and forming the dross. Okay. You stay there. Gotta measure. Boy, this is really hard. Okay. It's not big enough. There she is. Okay. Got to have a way of grabbing that. I guess this will be fine. See if we can grab it with this. Maybe. go. Starting to loosen everything up. Okay, that looks nice. Inside skin looks nice too. Let's see if we can do a little dusting. Take the edges off. I'm not necessarily worried that this is going to become a problem with dropping sand in there. Okay, let's get all this stuff out of the way. And I sure hope that does beep like it should. If it goes dead, battery I mean wise, it would really be disappointing that if that thing's been flashing but off all that time. Shouldn't be. Alright, let's get this out of the way. Now it's just a matter of taking these and smoothing everything out. Do I want to? We'll look at it. Well, apparently I did not do enough when it comes to parting sand, or parting powder. But the good news is all of this will be all back together. It's still squeezed in there even though it was latched. Oh well. I think I better lay that down just to make it easier to work with. Yeah, well, I'm going to have to remember not to trust those hinges anymore. Time for a little drink of coffee. I gotta get this baby all the way down. Where is it? Where is it? There it is. You can always tell when you get to the next layer is if you find a little piece of the plug that's got partene powder in it. Okay, well, as I was hoping, just at the end of that last sentence, it made the noise and it went and died. So, better than halfway through a sentence, I suppose. Now, what I need to do, I've already got this, whatever I wanted to do with this done. So I can get this put away, put over on the bench over here. Just to make it safe. And then take this apart. And really hope that the sand didn't ignore the partene powder this time. May as well get this side done before. I move things around, get this half done. I got a zigzag pattern down here in the sidewall here. Apparently, this has got some kind of a piece sticking out. I don't feel it. Maybe there was a harder piece of sand right up against it. Get you out of the way. Alright, let's see if this don't mess up. Hey, hey, this side did good. Yeah, see how it's indented in a little bit? Not the way I wanted it, but because the pneumatic rammer hit it on top a couple of times, it pushed it down a little. The sand did stick a bit, tiny bit. You can see little what looks like continents right in there. Okay, now what I was planning on doing, is I was planning on having the runners go this way and the swirl gate going this way on this side. And there's a problem though, is because I was going to do this on this level and on the next level. The next level is where that stupid sand got stuck. So, well, it happens that this is almost centered up, so I'll just do it the other way. So I'll just make, well, got to do the pouring basin first, a splash basin, I mean. One reason why I have this is to smooth down the stuff that we cut when we cut. Don't normally have to do that if your pattern has already got the gating system included on the board. Come on, stay in one spot. Now, where's my little marker? Okay. Now what you do is you have to aim the end gate so that it hits this wall here, or actually that wall there, at an angle that makes it want to follow this wall and swirl. That's why it's called a whirl. Whirl. That's why it's called a whirl gate. Just like this kind of whirl that you see when you flush your toilets, or just like kind of whirl that you see when you have a full, water bed, a full sink in your bathroom, and you pull the plug and it all goes down and has a whirl that it follows. Same thing here. So what I have to do is I have to cut a runner and cut an end gate. Now I'll do the runner here. I'll do the end gate over here. Because if I cut it in here, it'll be starting from the bottom. It's not really going to be hitting the side. It'll be starting from the bottom. And it'll be, how deep is this? About halfway almost. Now you don't have to go all the way to the edge. Don't forget, you're just trying to give the system a place for dross to go when it's being pushed by the good metal. get all the sand out of here as we possibly can. The good news is, this doesn't have a whole lot of delicate features to it that I have to be so worried about the air hitting it. Okay, doggone it. Getting. Ah. Okay, so need to go in that way. As I said before, get out there, it'll fly. I haven't seen a fly in ages, and now here I am. There's a fly. I'm entertaining the fly inside my place here. As I said before, that goes halfway. Yeah, that'll do. I could mess with this for hours. Try to smooth this up. Try to smooth that up. But basically, all I want is the inside of the shell of this metal to be clean, and that's why we are doing the swirl gate. Keep wanting to say swirl. Suppose it's all that does make it a difference. Okay. Got that done, run, backs up, goes into there, goes there. Okay, that half, this portion is done now. Let's see if I can put it on without dropping anything. Okay, now the other swirl gate, well, the other swirl gate's going to have to be on that portion, because this is where the runner's got to be. Now, what I want to do is I want to get this in here and not allow any sand to fall back down in there. No, I don't want to do that. Guess I'll just have to try and blow it out. what I'm trying to do right now, sorry for not speaking so much, I'm trying to conform this portion right there where it comes to the down sprue, trying to conform that to the hole so that there isn't any choke there. There's no constriction, there's no blockage at all in there. And I shouldn't worry about it so much because I know darn well that this will be hot enough to go everywhere. I just wish I could get all of that little tiny ledge out of there. All right. See, now there's a little tiny knife edge right there, and if it gets eroded away, the odds are real good that it'll just get shoved to the end of that. That's why that's there. You know, instead of just stopping where it comes into the mold cavity, you have this little extra right here. That's to trap any dross or sand that comes out of nowhere and gets pushed by the good metal. I think I'll leave that alone. If it comes loose, it'll get pushed to the end over here. And I think I'm done with this section. All right, let's go look at this guy. This guy, I'm less worried about it falling out than the other. Okay. So you got to be able to visualize things now. Okay, I've got this, and I push it there, and it's got to go in there, so it's got to go in there. Okay. And okay. Now we know this is halfway between the edge here and the opening. Okay, so as long as you have the opening to this in gate, at least, you know, right over the runner, you'll be all right. Come on, fingers. looks like it's going to go there. Okay. That's at least halfway. That'll be fed by that. And some of this stuff is separated. I don't like that. But it's way out here. It's not really going to be in the mold cavity. I really hope we'll be able to put the camera close to looking straight down, and I really want to show how it whirls. In this case, it'll be clockwise. However, the proof is in the pudding. If there was sand or dross in the mess and it didn't get stuck in the middle of this mass, that's the important part. Okay, see if I can put this together without things going horribly wrong. Whoa, love it. Seems like somebody got pressed with something else, because part of this lip here was, you know, like somebody pressed it in. Okay. The very first thing you do after you make your mold, cover it up. Okay, that way insects, moisture, somebody throwing a sweaty hand into the atmosphere, you know, moisture from the atmosphere, humidity getting into the side here. You know, the worst thing that can happen is that you can let water get inside this, other than the water you put in there on purpose. Okay. Always remember, water is not your friend when it comes to molten metal being poured. It will, you imagine you've got a big flow of lava coming down a hill, okay? And there's a bit of saturated ground right in its path, saturated by water, that is. The molten lava comes rolling over it. As soon as that lava touches that land, that more than 1,000 degree lava turns that moisture that's in that land into steam. Now, it's not going to go down. It's not likely to go sideways. It's going to go straight up where there's less resistance. Okay, that means it's going to take that molten lava straight up into the atmosphere, and it could just as easily go straight into you. Or if it's like molten metal, and let's say I'm pouring it in here, which would be a bad idea, but if it's freezing out there, I could just as easily pour it in here. But if I pour it in here and then I hesitate to call it an explosion, but it would be a steam explosion. If I have a steam explosion in here and a handful of that molten metal goes flying, look at all the, you know, you can't look, but look at all that flammable stuff over there, okay? A patch of that molten metal could go flying in there. I wouldn't know it until something went boom out of there because of it being exposed to the molten metal, the heat from the molten metal, okay? You got to prepare for that. If you're going to pour molten metal, prepare for it to explode. Expect it to explode, and then take your safety precautions, you know, based on that. Don't expect everything is going to be hunky-dory and you're never going to have a problem. The gods of the foundry, I guess that would be Vulcan, they laugh at us whenever we think that. Okay? And they say, heh, boom, and they get us. So don't make any assumptions of that you're always safe, because something will come around and bite you in the hind end. Okay? So we've made the mold. I didn't feel a whole lot of anything fall. So cross my fingers. We'll find out when we pour this. Cross my fingers that everything came together right. And in the next, I don't know, this is Wednesday. It depends on what's going on. I usually like to have the wife here just in case something goes wrong, and then she can call 911. You know, this kind of stuff, being by myself, I'm not going to hurt myself. Likely. Not likely anyway. But molten metal, you got to watch out. So, this is the second example of why, if you're, let's say you're a machinist, a second example of why you should be making yourself a foundry. Why you should be learning how to mold your own molds. Because it'll come in really handy. Now, you may be able to do most everything from a billet that you buy, or from a chunk of steel that you get out of a scrap yard, or something that you really have to have because of its tensile strength. But if you have a foundry with a furnace in it and a molding bench, you might just be able to save yourself some big bucks and make what you need, rather than having to spend some bucks and buying the raw materials and then make what you need. Okay? So, this little video is done. Again, I've got to clean up after myself, which is quite a mess. Except this, ramming that up with the pneumatic rammer, I used up probably a good half a bucket's worth of extra sand using that. But it was really nice and solid. Okay? Did I? Yes, I did. Okay. I just had the, hey, did I vent the top? Yes, I did. Okay? You get my age, you start getting a little drifty. Thankfully, I wasn't quite as drifty when I was still in the Navy. Not quite. There was guys I knew, they were drifty. But they were nice guys anyways. And girls. We had some gals in the foundry. They didn't like me so much because I wasn't one of those where I let them have a break being a female. You know, the Navy's main job back then was to teach everybody how to do things, and if they didn't do it, they weren't being taught, and I was the supervisor, so I had to teach them. I had to not just assign them to be a supply petty officer, not just assign them to, whenever they needed somebody to go to a working party, that they go into it, you know, the stuff that kept them from having to lift heavy weights. I never saw any of them refuse to lift heavy weights. They didn't like the fact that I insisted that they did everything that the guys did in the shop, but that was only fair to everybody. You know, it was fair to them for them to actually learn what they needed to learn. It was fair to the guys. Well, they got to learn what they need to learn also, but we didn't have to say, no, we can't have her do that molding because it's heavy. No, that would be wrong. Okay, especially nowadays. It's even worse now than it was back then. The insistence that females have for gender equality. Okay, well, I was doing gender equality back then. I didn't get in trouble for it. Nobody went crying to somebody. And if they did, the supervisor, like division officer or whomever they went crying to, told them to just, I was doing my job, shut up, go back to work. That's the only thing I can think of. I never heard any of the ladies, go crying about having to do heavy work. It was part of the job. That's what they went through A school for. I'm sure they realized that too. Anyway, that's enough of that. Okay, this is going to be poured in the next few days. Not so much because I'm tired, I don't want to do it, but because I'm married. Sometimes the wife has me by the something or others, and we got to go do what she wants to do. No biggie. This'll last, and you'll still be able to see what happens on the next video. Okay. In the meantime, Liberty Call.